In this video, we are going to solve the Leetcode problem of the day, and the problem is find minimum time to reach last room part 1. The problem category is of medium level, but I would say if you know about shortest path algorithm in a graph and if you understand the trick behind the problem, it is going to be really easy to code and really easy to understand. And that's what I am going to do. I am going to explain you everything about this problem and the solution approach. And after this video, you will find it very easy to code as well as very easy to understand. The given input in the problem is a two-dimensional array of size n by m, and let us call this two-dimensional array as moveTime. So every time I will say moveTime, it means that this two-dimensional array which is given in the input. Every index I comma j in the moveTime or in the two-dimensional array is a room, or you can say it is a node in a graph. So every index is a room. Now the output which we need in the problem is the minimum time required to reach the room number n-1 and m-1. For example, if the given two-dimensional array is of size 5 by 6, that is 5 rows and 6 columns, it means that n is 5, m is 6. So we need to find out what's the minimum time which is required to reach the room number n-1 comma m-1, which is room number 4 comma 5, right? If it is 5 comma 6, you need to go to the 4 comma 5 index, okay? And that's actually the last index. This -1 and -1 is there because the array's indexing starts from 0, right? So we need to find out how we can reach to the last room, that is n-1 comma m-1 indexed room, and what's the minimum time which is required to reach the room, okay? Now let us try to understand what's the question all about and how can we reach to one room from other rooms, okay? We can start from the room number 0, 0, okay? That is the initial index. 0, 0 is our room number 0, 0, and we can start from there. So you can say we are initially at the room number 0, 0, and we need to reach to the room number n-1 comma m-1. We can move horizontally or vertically, okay? So I will explain you this point again, but for now you can just understand it like this, that if you have a graph, okay? If you have a graph and all these points, all these nodes are your rooms. So from each room, you can either go horizontally or vertically, okay? I'm going to explain you this point in detail. Now, to go from one room to any adjacent room, it will take 1 second, okay? If you are at this point, you can go horizontally or you can go vertically, right? If you go horizontally to reach another adjacent room or vertically to reach another adjacent room, it will take 1 second, okay? So to go to any adjacent room from one room, it will take 1 second. This is a very important point, okay? We can only start moving towards a room at or after array of I comma j seconds. I haven't told you about what's the actual data which is given in the problem. We are given a move time, a two-dimensional array, and the indexes of that array is the room, right? But what about the data which is there in the indexes? That data is representing a time, okay? Now let us read back this point again. We can only start moving towards a room at or after array of I comma j seconds. That is, for every room number I comma j, which is the index, there is a data in the array, in the move time array, right? That data is representing the seconds or the time at or after which you will start moving towards the room. For example, if you have an input of 5 by 6 and at index 2 by 3, it means room number 2 by 3, the value is 10. It means that when you started at the point 0, 0 and now you are at a point from where you can reach to this room, then you can only start moving towards this room when you have already moved or already spent 10 seconds, okay? Now this might seem a bit confusing, but we are going to understand this with many examples, okay? So all these points will be cleared. Now let me explain you all these points again with inputs or with examples. This is the example number 1, which is given in the problem. You have a two-dimensional array and this is the data. Now what's the size of this array? It's 2 rows and 2 columns. So this 2 is the n and this 2 is the m. So n is 2, m is 2. It means we need to reach to the row number n-1, m-1, which is 1, 1. This is the 1, 1 index, right? Row number 1 and column number 1. We need to start from the room number 0, 0, which is the initial room, and we need to reach to the target room, which is the last one. The last row and the last column. That's the room number we need to reach. Now the output in this input or for this input is 6. Now how can we say the output is 6? First of all, this 6 means that if you start from this point or this room and if you reach to this room, it will take at least 6 seconds. How can we say this? Now, when you are at a point or at a room, you can only move horizontally or vertically, right? And you can move in all 4 directions because there is no mention of which direction you can move. You can move horizontally, you can move vertically. So you can move all 4 directions. Now this is about the point number 3 here, that we can move horizontally or vertically. Let us more focus on this point. This is a very important point. We are at this point for now, right? The point number 0, 0 or the room number 0, 0. Now if we start at this point, what are the different rooms we can reach? From this one, we can reach to this room and this room, right? We can move horizontally and we can move vertically. Well, we cannot move above and left. That's because there are no rooms, right? This is the initial one. Now to reach this room, how much time it will take? Now you can say that according to this point, to go from one room to any adjacent room, it just takes 1 second, right? Which is correct. If we try to move from this place to this place, it will take 1 second. But this is a very important point to understand, that we can only start moving towards a room at or after array of I comma j seconds. It means that if you want to move towards this room, you will have to wait for at least 4 seconds. Then only you can start moving towards it. You will have to wait here, you will stand here and you will wait for at least 4 seconds to pass. After that you can start moving. It's not important that you move to this room, but if you want to move to this room, you will have to spend at least 4 seconds, right? So we are at this point. You can move to this one and this one, right? Both of the rooms requires that you will have to wait for at least 4 seconds, and that's the thing you will have to do, right? So you waited for 4 seconds, and after 4 seconds you start moving towards this room or towards this room. Remember, our actual target is to reach to this room, right? And we don't know that which path will lead us to the best or the minimum time required to reach this room, right? So we are going to try all the path, but we are going to do it smartly. We will move towards this room and this is going to take 5 seconds, right? Why 5 seconds? Because 4 seconds we waited at this room and then we started moving. Now to move from one room to other room, it will take 1 second. So 4 seconds of wait time and 1 seconds of moving time is equal to 5 seconds. So we can say that to reach to this point, I will take 5 seconds, and similarly to reach to this point, I will take 5 seconds, right? I can directly go from here to here in 5 seconds. We can be at this point in 5 seconds, at this point in 5 seconds. Our target is to reach to this point, right? We will try to reach to this point from both the points. Now how much time it will take? See, it's going to take just 1 more seconds, and that's because to move to this room, we have to wait for 4 seconds, right? We have already spent 5 seconds moving to this room, right? So we are at 5 seconds, or the time is, or the current time is 5 seconds, right? So the wait time for this room is already over. Now it's about how much time it will take to reach this room. Just 1 more seconds, right? So if we start moving from this point to this point, it will take 5 plus 1 equal to 6 seconds. And if we start moving from this point to this point, it will take 5 plus 1, that is 6 seconds. So to reach to this point, we can follow this path or this path. Both are going to take 6 seconds. And that is why the output is 6. Now I know that this might still be confusing. So let me explain you this with example number 2. In example number 2, you have this as the input, right? Now you can write this in the form of a matrix. The size of your array is 2 by 3. So n is equal to 2, m is equal to 3. So we need to reach to 1 by 2, which is this point. That's the last room, right? We start at this point and we need to reach to this point. The output in this scenario is going to be 3. That is, it is going to take 3 seconds to reach from this point to this point. How? If you are at this point, you can either go vertically. If you are at this point, you can either go horizontally or you can go vertically, right? We can try both of it, and it will take total 1 second to reach here and 1 second to reach here as well, because there is no wait time involved, right? We can directly start moving towards this room because the wait time is 0. Now from this point and this point, from both of these points, I can reach to this 0, right? How much time it will take? Just 1 more seconds, right? Because there is no wait time. So if I start from this one, I can reach here in total 2 seconds, right? The path is going to be from here to here, right? 1 second and 1 second, total 2 seconds. Or I can say I can go here and I can go down. It is going to take 1 second. It is going to take 1 second. So total 2 seconds. Now again, I have to reach to this point and this point. That's my final target, right? Now to reach to this point, I can go from here, right? I can go right and I will reach to this point. Now to reach here, I took 1 second. I will take 1 more second to reach to this point, right? Total 2 seconds. So to reach here, I took 2 seconds. To reach here, I took 2 seconds. Now I can reach at this point from this one and this one. Both of them takes 2 seconds, and I can go here in 2 plus 1, which is 3 seconds, right? So the output is going to be 3. It is going to take total 3 seconds. You can follow 2 different paths. You can go from here, or you can go from here, or even you can follow another path, which is you can go from here, right? So you have a lot of different paths you can follow. Now there is another path, which is you can go from here, then you can go here, then you can go up, then right, then down. But this is going to take more time, right? 1 second, 2, 3, 4, and total 5 seconds. This is what it is going to take. But we know that we can reach here in 3 seconds as well, and that's the minimum we need. Now let us understand this with another example. If this is your given input, then the array is of 2 by 2, and we need to reach to the row number 1 by 1, right? Or 1 comma 1. We start from this point and we need to reach to this point. Now I can go at this point and at this point from this 0, right? But I will have to wait for 1 second to reach to this point, okay? Or to start moving to this point. So I will wait for 1 second and I will take another 1 second to reach to this point. So this will be like, to reach here, you will take total 2 seconds. And similarly, to reach here, you will have to have 1 second of wait time and 1 second of moving time. That is, you will take 2 seconds. So now, to reach here, you took 2 seconds. To reach here, you took 2 seconds. Now, can you reach at this point? Yes. How much wait you have to do? 2 seconds. You have already spent 2 seconds, right? So, no need to do any more wait. You can directly go at this point, and you can even start from here as well, and you can directly go to the final target point. So, the output is going to be 2 seconds plus 1 second. That is 3. So, you can go from here to here in 2 seconds. From here to here in just 1 second. So, 2 plus 1 is 3 seconds. That's the output. Let us take one more example. I'm taking too many examples because I want you to understand this problem clearly. Once you understand the problem clearly, it is going to be really a piece of cake for you to solve it if you know about the shortest path algorithm. That is what I'm going to cover as well. So in the example number 4, the input is this one, and the size of the input is 3 by 3, n is 3, m is 3. So we need to reach to the point 2 by 2 or the room number 2 by 2. I'm going to go in detail while explaining this input. Now, you are here, right? And you have not spent any seconds. You have spent total 0 seconds, right? So let me cut out 0. Now you can reach to this point or this room number, which is index number 0, 1, and you can reach to this point, which is index number 1, 0. So you can start from 0, 0 and reach to these 2 points. You can even try to go up and left, but there are no rooms, right? So we will not go up and left for now, but we can reach to this point and this point. Now, if you want to go from here to here, you will have to wait for 2 seconds, right? So there is at least 2 seconds of wait, and then you will take 1 more seconds, right? After 2 seconds, you will take 1 more second to reach here, right? So you will take a total of 3 seconds to reach at this point. So total 3 seconds, right? Now, what about this one? You will have to take at least 3 seconds of wait time, okay? So total 3 seconds of wait time, and then 1 more second to move from this point to this point, right? So we are actually trying to follow all the different paths, okay? Now, if I reach to this point, it will take total 4 seconds, 3 seconds of wait time and 1 second of moving time. So total 4 seconds for this point. So we have spent around 4 seconds, okay? There are two possibilities. We can either be at this point and we can be at this point. From this 3, I can go to this 4, this 5 and this 0 as well, right? I cannot go to left because there are no rooms, but I can go above. But I'm not going to go above because I have already covered this point, okay? I have already started at this point. I don't want to go back to a point which I have already seen, okay? So I will go at 4 and at 5. Now there is another path to reach this 4, okay? So I will cover this 4 later on, but for this 5, we just have this path for now. So if I go from this 3 to 5, I have to spend at least 5 seconds, right? Because I have a wait of 5 seconds. So after 5 seconds, I will start moving from here to here. So it is going to take a total of 6 seconds to reach at this point, okay? Now what about this one? You can reach to this 4 from this path as well as this path, okay? If you start from 0, go to 3 and then go to 4, you are going to take a total of 5 seconds. You will take 4 seconds to reach 3, right? And to start moving to this point, you will have to wait for 4 seconds. So you already took 4 seconds to reach 3. So the wait time is already over. You can start moving to this room and you will take 4 seconds of wait time plus 1 second of moving time, which is 5. Now, if we start following this path to reach 4, it's still going to be 5 seconds. And that's because even though we are at this point in just 3 seconds, I cannot start moving to this point. I will still have to wait 1 more second so that I spend total of 4 seconds. And then only I can start moving here. But that's the wait time, right? I have to wait for 4 seconds to start moving to this point. So after 4 seconds, I will start moving and this is going to be 4 plus 1, 5 seconds, right? Alright, so to reach to this point, it is going to take at least 5 seconds. I can go to this point and this point. These are the 3 different paths I can explore. Now for this one, what I can do is, I can follow this path. See, we have another path, right? We can go from 0, 3, 4, 6 and then we reach to 1. This is another possibility. I'm going to cover this, but this is actually the best path to reach here. We need to take smallest time to reach any point, right? So let us try to reach this 1 and let us follow this path. Now, if you follow this path to reach to 2, you took 3 seconds, right? Now to reach here, you can start moving to this point directly without any wait, because this room demands that you will have to wait for total 1 seconds and you have already spent 3 seconds in the field, right? So you don't need to wait anymore. You took 3 seconds to reach this room. Just take 1 more seconds to move from this room to this room. So this is going to be total of 4 seconds. If you follow this path, so we have a path to reach this room in 4 seconds. But what if we try to follow this path? We can go from 0 to 3, then to 4, then to 6, then to 1. Because from 6, we can go above as well, right? But we are not going to follow that path because it took total of 4 seconds, right? To reach this point if we follow this path. But if we follow this path, to even reach to this point, I took 5 seconds. So definitely I'm going to take more time to reach to this point if I follow this path, right? So we are actually going to try all the path, but we are going to store that value which is minimum for every point or for every room. Now what about this point? How much time we are going to take to reach to 6? See, I'm just randomly taking any room, but that is not going to change anything. Our logic is going to cover every path and every point. Now to reach to this point, what I can do is, I can start moving from 1 to 6, right? But to start moving to this point, I have to wait for total 6 seconds at least, right? And to reach to this one, I just spent 4 seconds. So I will wait for 2 seconds. So it will be total 6 seconds. Then I will start moving. So it is going to be 6 plus 1. That is 6 seconds of wait time, 1 second of moving time. This is going to be 7 seconds. So if you follow this to this path, it is going to take 7 seconds. And if you follow this to this path, still it is going to take 7 seconds. And that is because you are at this point in 5 seconds, right? You can just move here in 5 plus 1, 6 seconds. No. You will have to wait for 6 seconds. So to reach here, you just took 5 seconds. You will wait for 1 more seconds. So total of 6 seconds of time has been passed. Now you can start moving to this point. So it is going to be 6 seconds of time which is already passed or waited plus 1 second of moving time which is 7. So to reach to this point, the minimum time which it is going to take is 7 seconds. But if you start moving from this point to this point, it is going to take 7 seconds because to reach here, you took 6 seconds. Now you will take another 1 seconds. You don't need to wait anymore because it just requires 1 seconds of wait time and you have already spent 6 seconds, right? So you can just take 6 seconds to reach here and take 1 more seconds to reach to this point. So it is going to be 7 seconds. But what you can actually do is you can try to reach this point from this point, because to reach here you will take 5 seconds and you will take 1 more second, 5 plus 1 6 seconds to reach at this point, right? So this is the best path to reach to this point. So now we have found the best path here as well, and it is going to take 6 seconds. There is a wait time of 7 seconds to reach here, right? So you will actually spend a total of 7 seconds and then you will start moving, right? So once you start moving, it is going to take 7 plus 1, that is 8 seconds. So to reach this point, it is going to take at least 8 seconds, right? So the output is going to be 8. Why 8? Because this is our final point. This is our target point. So I think that's the in detail explanation of how is this problem designed. Now let us focus on the solution approach. The solution approach is simple. We are going to use the shortest path algorithm for a graph, and the algorithm is this one, right? This is a very famous algorithm, Dijkstra's algorithm. But the main question is, how do we identify that this is a shortest path algorithm problem? See, the thing is, we are having a two-dimensional graph or two-dimensional data, right? We can move vertically, we can move horizontally, right? This is generally how we do or how we move in a graph, right? Now, from one point, we need to reach other points. This is another proof that we need to treat this as a graph and we need to find the shortest path. But generally in shortest path, there is a distance which is actually your cost. In this question, the cost or the distance is actually the timing, okay? And we are going to calculate the cost or the time for every edge from one node to other node, okay? This is what we need to do. And then we need to find out what's the minimum cost at this point. What's the minimum time which we took from 0, 0 to n minus 1, m minus 1. Every room or every index I, j is a point or node in the graph, okay? And generally what we do in a shortest path algorithm, we create a two-dimensional array of size n by m, the same size which it is given in the problem. Now let us more focus on how can we solve this problem using this algorithm. We will create a two-dimensional array of size n, m, and this is going to store the answers or the shortest path or the shortest time which it is required to reach our index, right? Initially, each data in this array is going to be infinite. That is, initially we will not be able to reach any point. We are going to compute the answers for each point. Also create a set to store the visited rooms, right? That's because I don't want to visit back any room after I have already visited and I have already found what's the minimum time which it is required to reach a room, right? If I already know the answer, why do I need to reach back to that room and again start doing the same thing, right? So we need to create a visited set, and this set is going to store all the rooms which we have already visited. The room number 0, 0 is our initial point. So there is no cost or no timing involved to reach this room. We are already in this room, right? So what we are going to do is we are going to update the data for this room 0, 0, and we are going to set it 0. Other data will still be infinite. This is something which we can set as 0, this room. Also create a heap to store some data. Now what is this data? This data is going to store 3 different data. The current time we have spent to reach the room number I, j. So initially we are just going to store it like 0, 0, 0, right? That's because to reach to the room number 0, 0, we took 0 seconds because we are already in that room. Now from each room, we will try to move to up, that is the room above, or down, that is the room below, or right or left. That is, if you represent your rooms as a graph, then from any point or any room, you can go vertically or horizontally, right? So vertically you can move up and down, horizontally you can move left and right, right? So that's what it's written here, that we from each room will try to move up, right, down and left, okay? Now for each of the room, choose the smallest time which is possible. Okay, let us try to apply the same algorithm on this input. We need to create a two-dimensional data array, right? 0, infinite, 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 all are infinite. So we have created another data of the same size is given in the input, and we have set 0, 0 as 0 and other values are infinite. Okay, this symbol means infinite. As of now, this array is telling me that we can reach to the room number 0, 0 in 0 seconds, but to reach any other rooms, it is going to take infinite time. Now we are going to do some processing. We are going to create a set of visited. We have not visited any room, and let us create a heap as well and initially store it as 0, 0, 0. These two numbers are representing the room number. So to reach the room number 0, 0, the time which it took was 0 seconds. Okay, so this is the time and this is the room number. So we have created a heap. Okay, now we are going to get some data from the heap. We are going to fetch the minimum timing data, the data which takes minimum time to reach. So we just have one data, so you will fetch out a data out of it. So now you have a data 0, 0, 0. This is your room number, this is the cost or the time. Now you can move to other rooms, right? From here you can move to other rooms, but before moving, you will make sure that 0, 0 is part of visited, so that if you have option to go back to 0, 0, you don't go back to it because you have already visited this point and the value for this point is already 0. Okay. Now if you are at 0, 0, you can go above, down, right and left. Now to reach above, you will have to minus 1 from your I, right? So 0 minus 1 will be minus 1. So now the room number, the new room number in the above is minus 1, 0. But we know that this is invalid. We are going to check if we try to reach any room and it is invalid, right? So if it is invalid, we are not going to process it. So if you want to go above, you can say minus 1 from the I. If you want to go to the down, then you will say plus 1 to the I. So it will be 1, 0 if it is 0, 0. Now this is the valid room. If you want to go to right, you will have to say plus 1 to the J, right? So it will be 0, 1. This is your right room. This is the room which is right from this room. Okay. And you can go to left, which is like saying you have to say minus 1 to the j. Okay, so you will have to go up, right, down and left. You have 4 options, right? We are going to try all the 4 options and we are going to process all the valid non-visited rooms. So we know that these two are invalid, right? But the room in the right and the room in the down is valid, right? Now what is the time it will take to reach to these two rooms? First thing is you will have to see how much time you have already spent. You have spent 0 seconds for now, okay, right? Because we are at this point, we have not spent any time. Now to start moving to this point, I will have to wait for 2 seconds, right? So the formula for this is going to be like this. You are here in 0 seconds. You will take 0 plus 1, that is total 1 seconds to reach this point, but you will have to have a wait time of at least 2 seconds, right? So you will wait for 2 seconds. That's the minimum wait you will have to do, and then you will add 1 to it. So total 3 seconds you will take to reach to this point. So for now, let us say this is the answer at this point, 3 seconds, okay? Now there is another possibility which could happen. That is, let's say you are at this point and we have already spent 10 seconds, okay? So at this point of time, we are going to say 10 plus 1 is equal to 11. That is, it will take 11 seconds to reach at this point and not 3 seconds. So there are two different possibilities. Either you will say 2 plus 1 or you will say 10 plus 1 if it took 10 seconds to reach to this point, right? So we are going to take the maximum out of two different values. The maximum out of the wait time and the time it took to reach to this 0. This is the point from where we are trying to reach to this point, right? So we have to say how much time we took to reach to this point. Let us say it is x, and how much wait we need to do. Let us say it is y. So take the maximum out of this and then you will add 1 second. That is the time to move from 0 to 2, right? So find out the maximum of these 2 points, add 1 to it. That's the answer you will have for this point, okay? So for now, the maximum is going to be 2, right? Because to reach here, you took 0 seconds and you will have to wait for at least 2 seconds, right? The maximum out of this is 2. 2 plus 1, which is the move time, 3. So we have to take 3 seconds to reach at this point. All right. Once we reach to this point, from here, we can also reach to this point, right? How much time we will take? Now, we need to find out the maximum of 0, 3. This 3 is the wait time and this 0 is the time we took to reach to this 0, right? So it will be 0, 3. The maximum is 3 plus 1. That is the move time. So it is going to take at least 4 seconds to reach to this point, to room number 1, 0. Now, while we add this data, we are also going to add the data in the heap as well. So we are going to say, okay, we took 3 seconds to reach to the room number 0, 1 and we took 4 seconds to reach to room number 1, 0. So that once you process this data is out of your heap. Next time you also process these two data, that is when you are at the point 0, 1 and when you are at a point 1, 0. And this is going to continue. When you are here, you will try to reach this point, the above, the down, the left. The left is invalid. The above is already visited. You will go right, you will go down. And this is something we will continue doing until we reach to this point. And when you reach to this point, we are going to be out of the loop. And then you can return what's the value at this point, right? This value will represent the actual answer, the minimum time we took to reach this point, this room number from here, okay? So let me actually show you how the solution looks like, because that is going to clear a lot of things. So let me take you back to the code editor and show you the code in Python. Okay, so this is the complete code for this particular problem, and this might look a bit complex, but I'm going to explain you everything. First of all, you need to find out the value of n, m. So n will be the length of your moveTime array, and m will be, that is the number of columns, will be the length of any of your row, right? Now you create a distance array of size n, m, and each of the values is going to be infinite. You create an array of infinite size. First of all, you create the columns, and then you run a loop for the rows, right? So this will create a two-dimensional array of size n, m, and all the values going to be infinite. Create a set which is named as visited, where we are going to store what are the visited rooms. Then update the value of the distance 0, 0, that is the room number 0, 0 is 0. That is, we are going to take 0 seconds to reach this point or this room. Now create a heap. This heap will have initial data 0, 0, 0. This 0, 0 is representing the room number, and this 0 is representing the time which we will take to reach to this room. Now run a loop while we have some data in the heap. First of all, we extract the data. So we will say heapq.heapPop. This will pop your data using min heap. So this is going to be optimized, right? Now we have the time, we have the room number x, y. This is the current room, right, where we are at. So we will say if this x, y is already visited, then you don't need to do any processing, just continue. But if it is not visited, add it in the visited set. This is going to be visited.add x, y, right, as a tuple. Now we are going to run a loop in all the 4 directions. This means you need to go down, this means you need to go up, this means you need to go right, and this means you need to go left. So all the 4 directions, dx, dy, right? And then your new x and new y is going to be x plus dx and y plus dy. That is the new room numbers where you can reach from the point x, y. Now, if the new room number nx and ny is not valid, if it is valid, it should be within the range of n and m, right? If any of the value is out of the range, it means we are actually trying to go beyond the boundary or to a room which is not valid. So once we identify a valid room, we need to find what's the new time. Now, what is this new time? This is the amount of time you will take to reach to the new room if you start from this x, y. Now, if you start from x, y, there are 2 possibilities. First of all, you will find what's the distance we took or what's the actual time we took to reach to the room number x, y. That's one possibility. And there is a wait time, right? Wait time is given in the move time. So what's the wait time in your new room? So you need to find the maximum out of these 2 values, because that's the minimum wait we have to do if we want to start moving to the room number nx, ny, right? Just take the maximum out of this, add 1 to it. This 1 is the actual move time from room x comma y to nx comma ny. So we can move to this new room in new time, right? This is the new timing. But what if we have already found a way to reach to the room number nx comma ny and that time is less than this new time? If it is less than the new time, we are not going to update any value. But if it is more than the new time, let us say the already existing value to reach to the room number nx comma ny is more than the new time which we found, then we are going to update our value. We are going to say distance for nx comma ny is the new time. And then we are going to push this data in the heap. We are going to say heap q dot heap push. We need to push the data in the heap array, and this will be the time we took to reach to the room number nx comma ny. So after processing this data, after processing every data in your heap, we will come out of the loop, and the distance array is going to store your answers. We need to return the answer for room number n comma 1, m comma 1, right? So we are going to say return at index n minus 1 and m minus 1. So this is the complete solution for this problem. Let me actually maximize the window and show you the complete solution. So yes, this is the complete solution. You can take your time to understand the problem and understand the solution as well, because once you understand it, this will be very easy. But don't rush, because this might take some time to digest, right? So yes, now you can submit the code, and this is going to solve all the test cases, and this is actually pretty efficient solution for this particular problem. So yes, we have solved this problem, and this is a good solution for this one. And that's it for this video, guys. If this video helps you to understand the problem and understand the solution as well, then make sure that you hit that like button. And if you have any questions, then make sure that you put it in the comment box. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel. And I will see you guys in the next video. Thank you for watching this video, guys.